has anybody heard of open source before? Does anybody use open source packages? All right. Let's maybe take some volunteers. What packages do you use?
I use a package called Cartopy for Cartopy for like mapping stuff.
Cool. And do you know who built that?
No.
Anybody else? What about you?
Deep Lab Cut.
Use Deep Lab Cut. Actually, I used to use Deep Lab Cut in lab also. We used to track like beetle and ant interactions. Yeah, I think that was an academic effort, right? Deep Lab Cut.
The Mathis Lab.
Which one?
The Mathis Lab.
Mathis?
Started at Harvard.
Oh, cool. Yeah, Deep Lab Cut is actually surprisingly good. We're going to be talking about some similar tools to Deep Lab Cut. I think Deep Lab Cut is like key point identification and semantic segmentation, which we're going to be talking about. We have the slides. Let me go to the next slide. So this is just hitting in the previous question we just went over. Like, when should you use open source code? In my opinion, you should try to see if you can use open source code before you try to develop your own software solution from scratch. And we'll give you some examples of open source code that might be helpful for you in your use case. So there's a significant movement in machine learning open source frameworks such as Pytorch. How many of you use Pytorch? There's one. There's two.
Everybody here is going to.
Okay, so it's okay. So if you haven't used Pytorch yet, I highly recommend looking into it. Likely by the end of the week, we're going to be having you train your first model. So likely it'll be in either Pytorch or TensorFlow, which is another major open source machine learning framework. One was developed by Google, the others are by Meta, and so these are like competing frameworks, and they're very, very highly sort of supported. And they're actually making it very simple for you to use whatever downstream application you have. So, for example, if we all worked on getting your data into a Cocoa framework, and once you have that, you can load it into this dataset object, load a model using this model class, define what is known as an optimizer, which I don't know if you've covered, and I'm happy to answer questions. And then you can just iterate over your data and train your model based on the images or examples in your data. And this is a sort of code snippet that lets you sort of look at what are the important steps in doing that. But generally, I don't know if we want to go into detail now, but we'll talk about it.
I think the important point here is just like, if you're doing something simple that's supported in native Pytorch, which is like what we're going to look in, like what's already built into Pytorch. This is literally like all the code you need to actually train that model. As long as it's pretty simple and you're not really changing much, like that's it. That's all the code you need to train a model in Pytorch. It's pretty amazing.
Really?
Yeah.
All right. For what it's worth, it gets even simpler with like frameworks like Pytorch Lightning.
But so actually this is something we went down this path last year and we learned a huge lesson from it. There are wrappers around native Pytorch that mean you can train a model with a single line of code.
Yeah.
As a result, those wrappers abstract a bunch of things. So as soon as you start wanting to change anything, which is what we want to teach you how to do here, like to be able to actually dig in a little bit under the hood, understand what things are going wrong, and actually make some changes, using something like Pytorch Lightning makes it very, very, very hard to change stuff. So we're going the one layer down from like single line of code training with the idea that then it'll be easier for you to go to that. But we really learned some painful lessons last year about trying to teach with those wrapperized things. And I actually feel the same way about our wrappers around Pytorch code, where like if you want to change anything, it gets really messy. So this was our lesson learned. And so we're going to go with simple models in Pytorch if they're supported.
Yeah, sounds good. For what it's worth though, it's on the latest version of the slide. Do you want to refresh that?
Oh gosh. Oh well, it's all right.
And so I was going to say that I don't know how it is to train a model using R, but I do know that there exists TensorFlow, exists in Keras, which is another wrapper on top of TensorFlow, exists in R. So I know that it's also possible if you are more familiar with that. Here we have a quick slide on what Pytorch already has. So this is specific to vision. They also have audio and other modalities, but in vision they have a few canonical tasks. such as classifications. If you want to identify, whether something is is night or day, you can, it's a classification task. If you want to do semantic segmentation, which means you want to identify a certain object and identify the boundaries of an object all the pixels belonging to an object in an image. Object detection, instance segmentation, and person key point detection, and video classification. They have canonical models built in for each of these tasks. Now, in classification, there are actually different models that have different performances, and in Pytorch, they, in a table below this one on the website, in the link above, they tell you the performances of each of these models. So if you were to
on ImageNet usually, or Coco.
On a specific data set. So if you were to, and they also have links to what is known as a recipe. So if you went and followed the exact steps on that recipe, you should get exactly that number, which allows you to test your, the other stuff like, the install packages and other stuff that you've been working on. And this also allows you to pick the best model for your task. So if you, let's say, have like some constraint on how much space you have or how big a model you want to use, or how much training capacity you have, you can see like you can trade off to that for performance, for example. We also have a few models for other tasks that I mentioned, so like object detection, instance segmentation, and person key point detection. But generally, the takeaway is that there are like a few models. There's like maybe a handful of like all of 5 or 10 for all of these tasks put together. And so this generally is quite limiting when you compare it to other open source models that I think Sara will get into.
Mm-hmm. Yeah, I think specifically the point here is it's great if kind of the best option for you is already supported in native Pytorch, because you don't have to go find another repository, like learn to work with it. There's a ton of flexibility. And we strongly recommend that anyone who's doing classification as their first task, that they work from that example code that Benny generated that really is basically a really clean, simple way to work directly with native Pytorch models. But if you're doing object detection, it turns out that what's natively supported in Pytorch for object detection isn't the best option. And so that's kind of where we're getting into some of this stuff. So if you search object detection, actually, this was from last year. I didn't update this slide. Last year, there were close to 37,000 different open source repositories on GitHub for object detection. So how do you decide what repositories to use?
That's a great question. So I usually, if there's a group I know who release a product, it's usually helpful because some of these may not work out of the box in your settings. And so you can always ping someone and like if you have a connection with them to be able to work on like something. For example, DeepLab they had a similar software called Bento. We knew the people who developed that, so we tried to bias towards using that one. Obviously, you can also use the number of stars. I don't know if you see here, like, the 10.7K.
Yeah, but yeah, see here, there's like, you can look at the number of stars they have. That's basically like social media likes for software engineers, but a lot of stars usually means, or a lot of forks is something like when you go into these, you can see how many times someone has actually like taken that code and then started adapting it for purposes. A lot of activity in a repository is usually a very good sign, because that means someone else has worked out the kinks and hit the bugs, and so you're less likely to get bogged down hitting bugs, because there's the sheer volume of people working with the code means a lot of the bugs have been addressed already. Yeah, and you also have, if it's important to you that if the license matters, if you work for like a for-profit and this is something that you make money out of, it's probably important whether you can use the particular software in your tool. But yeah, I've never worked with that. I've always worked for nonprofits, so maybe. Yeah. No, yeah, so these licenses, and if you guys, have code on GitHub, we actually also recommend you put a license. But I pretty much always go with either the MIT license or the Open Commons license. There's like some really standard ones that I just pull in, and it's basically just a license that specifies how and when the code can be used. Yep.
You just mentioned the MIT license, and I started to have mixed feelings about it because, for example, in the R world, they kind of force you to stay open source because MIT allows anybody else to build a commercial product on software,
So I personally have become resigned to the fact that for-profit people will maybe just use the code regardless, and you end up running into like weird barriers and red tape on other sides. So at this point, I've given up. I'm like, open source, non-restrictive license makes it easier for me to collaborate no matter who I'm collaborating with. I do not think I'm ever going to make any money off of my code. If someone does take my code and like productize it up and start to sell it, and that's really helpful for the community and they're willing to pay for it, that's great. I'm going to maintain the free version, and like, I'm not going to make any money off of it. I don't really care if someone else does. That's my personal, I don't know. Everyone needs to figure out what that means for themselves. And actually, like, you know, if you are like a company, like Justin K has a computer vision company that does fisheries monitoring, that then changes things, right? Like, yeah. So the really great thing with these open source repositories is they basically have built-in implementations of a ton of stuff that can be a pain to write up. So you aren't going to need to write like code that will flip the images and flip the corresponding labels of your segmentation so that it matches, and like making sure that you're not somehow in your data augmentation, like mismatching your data with your labels. They have like tons of this stuff already built in, tons of different loss functions built in, lots of evaluation built in. Essentially, you don't need to reinvent the wheel. Someone's already written the code, and it's great to be able to stand on top of that and use it. And sometimes they have really well-vetted implementations. And well-vetted here, I mean, is like a lot of the bugs and the kinks have been worked out by just people doing it, using the code, hitting the bugs, and correcting them. But this is the big con of using an open source repository, is you need to then be able to read and understand someone else's code. And that's not always easy. And I think that's the big gist of this lecture, is we have this little intro at the beginning, and then the rest of the time is essentially a community-driven scavenger hunt through the YOLO repository. So I'm just going to ask for volunteers, ask for people to come up, and there's like little like scavenger hunt tasks, and one person's controlling the computer, everyone else is helping them. You're going to call out, and we're going to try to find the locations in this repository that will help us figure out how to use it for our purposes. So it's going to be like a fun community-driven thing. I got the feedback last year from a couple different students that this was the lecture that helped them understand how to work with Python code the most, just as like active activity. The other issue is that they're not always well documented, and this is another one of those things I look for when I'm looking at repositories. If they're like README is like code for this model, that's it. I'm like, uh-oh, seems bad. The other issue is that sometimes they're way heavier weight than you need. They're way more complicated than you need them to be. You only need one little piece of it, and this is this huge full-blown repository that supports 20 different possible end tasks, and that can actually make it more difficult to navigate. But often it's just a trade-off, and you just find the thing that seems to work best for you. So kind of getting back to how we know what's good, we mentioned a few of these already, right? I think you mentioned, so say we've read a paper and we want to try that model, right? This is often how I end up finding open source repositories. I read a paper, this is a RetinaNet paper. It's a different type of object detection architecture. I want to try it on my data. So I Google RetinaNet, and there are 900 repository results. So there's still a bunch of different repositories. Now, the things you want to look for in those repositories is you don't want it to be something where there's no documentation. If you look at the code and the data is hard-coded into the repository, so they haven't thought at all about making it flexible to work with different people's data sets, that's just going to make it really hard for you to use it. So you want to like check and make sure it sort of supports bringing your own data set to that repository. If there's like no stars, no forks of the repo, it might just have a lot of bugs, or it might just be not very well written. And so,
I've done all these mistakes in my own repository.
Yeah, I mean, me too. But I'm just saying, maybe that's why people are always using their repos, you know? Yeah, exactly. Or if there's no pre-trained model in the repo, that's actually also something that's just not going to be great for you, because there's kind of this thing where the weights of a pre-trained model on ImageNet is usually where you want to start, but you don't want to start by having to pull in this repo, download the ImageNet dataset, train your own pre-training weights, and then start from there. So you're looking for places where they have pre-trained models, pre-trained on different data sets. There's like a model zoo, and it's all kind of accessible. So there are a few really well-established repositories that are good places to start. How many of you guys have heard of or seen any of these before? Detectron 2, Torch Geo if you do remote sensing, Pytorch Video if we're working with video data. There's this great repo for segmentation just called Segmentation Models. Has a lot of different models supported. The TensorFlow Object Detection API, though that one's actually slowly being basically like, I don't know, stopped being supported. So, and TensorFlow is a bit shady. So I would actually maybe not recommend that one. But if you do want to work with TensorFlow, that is there.
Why is it shady?
Oh, no, it's just really annoying to use. The errors are kind of obtuse. It's harder to poke what's inside the models because they're kind of wrapped in these like graph structures. And so it can be much more difficult to debug. I say that as someone who works at Google and has written mostly TensorFlow code for 4 years. But like, it is easier. And when I'm outside of Google, I use Pytorch. Okay, so we're gonna do a scavenger hunt. So you guys, and the way we're going to do this, do you guys like scavenger hunts? I actually really do. So this is basically all of us right now. And we've decided that the right starting point for everyone doing object detection is this YOLO V8 code base. It's really slick, it's really well supported, it's super nice. It actually supports a bunch of different downstream tasks, but we're going to focus on object detection for today. And so, who wants to be my first volunteer? Be brave. All right, awesome. Valentin, come on up here. So what I'm going to have all of you do is go on GitHub and like Google Ultralytics, YOLO, and get to this repo, because you're all going to be following along and helping. So you guys are going to shout out if you figure something out, help Valentin get there. And then these are basically the set of tasks. Is this open source code scavenger hunt? I will share this link in the Slack. And so in case anyone wants to take a look. Okay, so Valentin, because you were the first volunteer, your job is not too difficult. Where is the documentation?
I would go here. Docs sounds good. If I click.
Awesome. Yes. Fantastic. All right. You get to call on someone else to come up.
Can we look at the docs a little bit? Because something I'm always curious about with docs is like how much they like explain the package to you versus how much they just list all the functions and methods.
Yeah, sure. Great. So
well, it has this where to start thing that seems intuitive. Like I would like to know how to install the tool. Most probably when I arrive here, I already know that YOLO is for object detection, no? So then, well, the brief history is a bit extra for me. I don't really want to know about that at the moment. I think license is useful.
Super.
but I guess
What was your question, actually?
I think he just wanted to say, like, let's take a look at these docs and see if they seem usefully structured. But I think we will get into that, Sam, too, like as we're actually going through the process of trying to figure out how to do stuff. All right, so Valentin, you get to volunteer one of your friends to come up next.
Martin, he needs to learn about it.
Hey Sarah,
Uh-huh.
is the reason why mega detector is based off YOLO V5 just because when it was
Oh yeah, like the last time that we had the money to retrain that model, YOLO V5 was the best option. Yeah. We might retrain something on YOLO V8 if we can figure out some weird politics about getting data things re-signed outside of Microsoft. And anyway, yes, the answer is it was the best option when we trained it. YOLO V8 came out like this summer. maybe a bit sooner,
Spring.
spring, but yeah, like recently.
That's a bit
So, yeah, so your next thing is, the document. The next thing for you is where, if we want to train an object detection model, what options do we have? So how do we figure out what are the different architectures that are supported within this YOLO V8 repository? And you guys call out, help him out if.
Well, I guess the documentation would be useful for that.
Mhm.
But I read this documentation yesterday and it's super scarce, but okay. Should I go there?
Yeah, no, you're just doing this live, yeah.
So object detection.
Object detection.
So we have, there was something on tasks, but it's not here, okay?
On the left, under task, there's detect
In the menu.
menu on the left.
Oh, the left hand side, yeah.
You mean here?
Left.
You're
Down. Don't keep going there.
Tasks, detect, yeah. This, but it's not here. So the question is exactly what type of
Which models are
architectures, I
supported,
mean,
yeah.
I mean, they're mentioning here just the versions of V8.
Yeah.
But I think that's what we're looking for, right? Like that, those
This
are
is-
the options.
This is what we're looking for. So for this repository, it explicitly supports, and this kind of makes sense, YOLO V8. So it has different versions of YOLO V8, but it's not like on this repository, you have like YOLO V8 or faster RCNN or mask RCNN or RetinaNet or whatever. There's some other repositories that have a lot more options. This one only supports these, but they work really well and they're really efficient. So this is what we're looking for here. So awesome. Martin, who's next?
What are those models? Like, you
Yeah.
can tell what the difference is. Just performance.
You can see, so for example, they've summarized the differences in this table here, right? Like the performances are different, speeds are different, the sizes are different.
And if you want to know the explicit details about the architectural, like the number of blocks or layers, whatever, that's definitely visible in the paper, or you can click on the link and you can actually read the configuration file for them that will like tell you the
Cool.
nitty gritty details.
For what it's worth, I think it's like nano, small, medium, large, XL is how it goes.
So it's like small to big.
Yeah.
All right, Martin, call in someone else.
Actually, another question about that. Are there are there just general rules of thumb on where you should start with what size model given certain size data set or something like that?
Well,
General rules of thumb is tricky. I always start with YOLO, like with YOLO V8, I would start with S. And I don't know why, just vibes.
We found that. I mean, for us, S is more generalizable,
Yeah,
which is good.
yeah. But I think it's a bit like it's like there's not like, because every model type is so different from each other that kind of like what's the right starting point will be different for different ones and for different use cases. Like I usually start with a ResNet 50 if I'm training a classifier. Some people always start with a ResNet 18, but I've just found that feels too limited for my data enough times that I just always start with a ResNet 50. But that's like, some of it's like intuition and it's stuff that you kind of build over time. Sometimes I just ask my friends. If I know someone's like worked a lot with YOLO, then I will. Uh-oh. Did you unshare the screen?
No, I was just started to reconnect somehow.
Weird. Okay. Anyway, sounds like you volunteered yourself to be next, Maddie. asking great questions. All right.
Way back.
Yeah, it looks like it just stopped sharing the screen for some reason. No? Yes?
oh.
Sorry, guys. All right. Cool. Good. So the next question is, how do you actually specify what model type you want to use when you train your model? So let's say we've picked YOLO V8S. How do we decide? How do we tell when we're launching model training the model that we want to use?
Yeah, often code bases in like their README will have like the super bare bones quick start thing, and I would imagine that's sort of where you might do that. Wait, let me reread that question. So it's right there. How would the model when you want to train? Yeah, it looks like it's right here. So you're loading your model. Here's your weights, and I guess this is the. Oh no, this would be the weighted one.
Mm-hmm.
Yeah, I guess that's it.
Yeah, and so one thing I immediately see here is that the structure that model information is saved in is either a YAML file, which is just the structure, or a .pt file, which is actually has weights, has those pre-trained weights in it. Cool. So calling someone else, Natty?
I'm not raising my hand, I just have a question.
Yeah.
So then if we look at that code file, your data would be whatever coco128.yaml.
So actually, that's the next question. So you volunteered yourself to come up and So how do we use our own custom data? What file format does the code expect? And let's find a dataset configuration file that we would adopt for our purposes.
So that's, how do we use our own custom data? Well, I have no idea. Anybody else?
Well, let's look at the docs. Maybe we go to the docs.
In the docs, these docs?
Not those, there's a.
It's also like a data set guide on that same page.
The tab is already open.
Oh.
Data set format, maybe?
Where?
Go back where you were.
Tasks, detect.
Data set format.
On the left again.
Data set guide.
Cool. So yeah, this seems like how they expect data sets to be formatted. So they expect you to write a file that looks like this, that defines how your data is structured. So it's simple. So what's the what does this look like? Like the simplest, you need to have a train folder and a val folder that you write into this file that are accessible. And you need to set a root directory that sort of is added to the beginning of like path plus train or path plus val will get you to the data that you actually want to train on. And then you also need to specify your classes.
Okay, so this is like a MATLAB file, this right here that you made?
So
Text file?
I think it's a YAML file. .yaml. It's just like that structure. And if we go back to the code base, the actual GitHub, let's see if we can find an example config, an example of this for a given data set that we could then actually just copy and then just adapt for our data set.
Okay.
So anyone have any suggestions for which folder we should go into first?
Examples.
Sense. Look at the README. No.
Example applications. Yeah, that doesn't seem quite right. So yesterday, Bjorn was talking about how in a lot of these repositories, there's going to be a folder that's named the repository name where most of the code lives. So I would check that one, that Ultralytics one. That's like where most of the code lives. Okay, so now where do we go?
Data?
CFG?
The config?
Yeah, that's always all the different configuration files.
Okay. Default?
Now see data sets are. Sorry. Whoops.
I'm like, stop giving me answers, man.
Too wide.
Ooh. So this looks like a bunch of different data sets.
Okay.
Yeah.
So you would make a file like this for your data?
Yeah, and often I'll even just copy one directly and then just change it for myself.
Okay.
And they are these .yaml files. So that's the expected format. And it's pretty simple, right? You just say, this folder is where all the training images are, this folder is where all the validation images are. If you have a test split, this folder is where all the test images are, and these are my defined classes.
And what's a YAML file? I know we talked about it, but
I actually, this is like,
It's just a
You load it in, it's a dictionary, so it's like a Python dictionary.
okay.
but sort of like a JSON. This is also, if you load it in, it's a dictionary. It's just like another sort of file
Like a
format.
list of
Mhm.
information.
It's easier, I think YAML files are more human readable than JSON files when you open them, which is a nice thing.
It's like markup for JSON, so you don't have to write the whole thing out.
Yeah, exactly.
And then where would your annotation, like your bounding boxes be?
In the .text files that you're routing it to.
So those lines right there, 10 through 4 equals 13, where you're pointing to things, is that where your data lives?
Yeah, so you should have images alongside text files named after those images in that same repository.
So that's where if we go back to that documentation about the data sets, like the format.
It's below.
So if you scroll down, then it decides, okay, so if there's no objects in the image, you don't need a .text file. Otherwise, you need this associated .text file for every image that defines in every row the list of associated boxes.
Go down further, you see an example.
Oh, and these are in the center as opposed to in the corners.
So they're specifying that the origin is the top left.
Yeah.
Yeah.
Okay.
I did find they do have code, intrinsic code for converting from Cocoa format to YOLO format in this repository. I think I put a link in the Slack. I've never used it before though, so I can't like tell you that it's perfect. But I imagine that it would hopefully be pretty well supported.
Great.
All right, so call someone else.
Cicely.
And Cicely, you're gonna try to find the default training configuration file. And then we're gonna look through it a little bit. Mm-hmm.
Is it on your Chrome? Oh no, it's just here. Default YAML.
Nice.
So what are the things in this default file? Like, say we want to train this YOLO V8 small model on our own data set. Where do we have to change stuff?
You mean like from the settings or? Because if it's default, you'd want to keep
a
it
lot
the
of patience, I think.
I would imagine if you want to train it on your own data, but you want to keep the default settings, you'd probably just change the data. And
Yeah,
then
so how do you do that?
The paths for model and data.
Yeah, yeah, that's what I was trying to go for.
Oh, sorry, I thought you meant the mode train.
Oh, yeah.
Because if you just want to train it first, you'd maybe just do train before you look at val or predict.
Exactly. But in order to run from a config, you need to specify what model you want to train on and what data you want it to train on. And so that those two paths in the training settings, those are actually not, they're not actually set. And then the other paths that are not set by default are, for example, device. And that one's actually an important one for you guys because you're sharing GPU nodes. So you are actually going to want to specify the device with your like node ID.
Actually, we already defined for each one of them access to.
Oh, so they
don't.
oh, okay, never mind. That we made that simpler. So yeah, you only have access to some of them, so it's fine. Cool.
I have a question.
Yeah.
Your image size says 640. Is that 640 by 640?
Yeah.
Mm-hmm.
Okay.
So this, yeah, if there's just one, you can assume.
Yeah. So there's just one number, then they have the same dimensions, 640 by 640.
So then do you need to rescale your images to fit that?
No, because this model is expecting that. So then in the data loading process, it will automatically resize the images to the expected size. Now, what you might want to check is what it's doing to do that automatic resizing. For example, if it's really important that you keep your aspect ratio the same, then you'd want to check that the parameters you've set for that data loading are padding the image instead of warping it to resize it. So this is kind of getting into some of the more like, how do I actually make changes stuff? So maybe so maybe Cicely, you can tackle how do you launch training from a config? So say we've named this Cicely.yaml. How would you actually launch training from that config?
Do you mean running the config file? Or like how would you edit the config file before starting it?
So you've edited it and you've
Okay.
already got it all set up for you.
You can
Now,
maybe
how do you
just
actually do it?
Start with this, so you would be loading your model from the YAML rather than the weights, because you're not trained it yet, right? So you'd presumably be using the pre-trained model and then testing it on your own data. So you would just edit the default YAML to your own data. Maybe I would make sure the name of the model I'm using is in the YAML file.
But so actually, I think there,
But they also have their data separately in this example.
so here, I think what they're doing is they're loading a
Might just be
model YAML,
Yeah.
which defines the model. And then they're training with a data YAML. And so here, they haven't actually used a full config for train. They've actually they've defined the model and the training data separately. But so what if you want to just, in your code, have a config, like what we just looked at, that defines the model and the training, and you just train on it?
So would you just do model train with the whole YAML rather than having like a separate one for the model and the data, presumably with the same argument, you can just train a whole YAML?
Yeah.
Because it's combined, the other one, right? You load your data in it and you load the model.
Mm-hmm.
So there should be an option to do model YOLO with like I don't know if you'd have to specify data and model from the same file.
Let's see, what are the options? Let's go look at the actual model, like let's go to the detection task and see what the options are for that .train function. In the code, I think.
Be under Ultralytics, maybe.
So any suggestions, you guys? Oh, yeah, okay.
Train?
Yeah, this is totally what I would look at.
You said run it all from the same YAML. This would be.
I just want to scroll down and see what it's
They call
inputting
it
for
a
train. So where's the train? I think it might be right at the bottom. Yeah, so there's this defined train function.
Yeah.
And it can take in CFG.
Which you can have as you just specify default CFG as your YAML, presumably earlier.
Mm-hmm.
Yep. What default CFG?
The other way to go about this, I had to dig a little bit to find it, but they have like a full API reference side of it. They're like.
Can you help her get there?
Yeah, if you go to the documentation, like their website documentation, in the other tab, there's that little energy saver thing is blocking it. But the reference tab on the right hand side there. So that's like every single method available to every single modular class that they offer. And I just there's like a model section in the that's the sidebar there. And if you scroll down under the models, there's a YOLO. What one is the YOLO?
The train one.
Scroll up real quick. Or other direction. No, oh yeah, so not an engine, rather, I would close that. And then scroll down to models where it says yep. And then in that list, there is a YOLO, sort of at this, yeah, there we go. And then in the train right there.
Probably for detect, I guess. Annoying.
Oh, yeah, anyways, not easy to navigate, I had a hard time finding it, but it is in there, yeah, there you go.
Beautiful.
And then there's it shows you like, how to pass in the config as an argument.
So basically, all this part of the documentation is defining the input variables and their expected formats for like the different functions, which is quite useful. You can also look this up in the code directly, which is what we were sort of trying to do. But sometimes the documentation can be a little bit easier to scroll through.
Just also a plug for using the question mark. So if you're used to R, you can like help a function. In Python, either in a notebook or in an interactive shell, you can always just type something's name in a question mark and it'll give you exactly the documentation that's on the website.
Yep, that's awesome.
And it'll tell you the arguments and the default values.
Cool. Okay, Cicely, we'll call on someone else.
Kyra? Sorry.
All right, Kyra. So, what's next?
Oh.
Oh no. So we already answered the input size. What input size they expected.
How do I fix it? How do I fix it? I don't know what's happening.
Either. I feel like something's like, it's kind of glitching out. Try, what I did last time. Just unplug it and plug it back in.
Yeah, is it just loose?
I don't know. Oh, I don't want the AirPlay. Is this loose? Sorry, guys.
Well, even like.
I gotta give you a super and stuff.
Wow, okay, we're back to this thing. All right.
Yes. Okay. We already answered the question.
You're going to want to look at if you can change that input size for your model. So say you actually want to train with a larger input image, what would you do?
So doesn't give me much. Loader. Usually there's like a class that defines.
Was that 640 thing on the default YAML?
Yeah.
We change that to a different number?
Yeah. So the real question, which is a little bit more of a tricky question, is whether if you change that, it will actually let you. Because sometimes the way these model architectures are defined, changing the input size to something that's maybe not like the right like power of 2 or something might break something. So you can do it the right way, which is like read all the documentation and check and see, or you can do it the wrong way, which is like change the number, try to hit train and see what happens.
Can I do it the wrong way in this course?
How about change the number, look at a preprocessed sample, and if it works, then proceed.
Exactly, perfect. Okay, so the next thing, Kyra, that I'd like you to try and find is how is the data pre-processed by default? What is like the processing and the data augmentation, or actually let's just do data pre-processing. So what is the default pre-processing of the data? When the data's loaded in, what happens to it?
We still have the Sure.
There's another, or there's another tab that's the actual code, or we can do it in the doc.
That's why this is minimized, right?
Oh, I see, sorry.
Yeah. This is the only other tab that's open. There's a bunch of stuff. Batch. Go over to train. Protection trainer. Batch. Looks like all it does is changing the array to floats.
Yep. Cool. So one of the things that I always like to check is there some default normalization of images that is happening in these models? And the reason I like to check that is like sometimes there's hard-coded in machine learning models image normalization that normalizes the red, green, and blue channels of the images based on the like the empirical average normal values of those on the ImageNet data set. And that might not be true for your images, and that might actually really affect performance. And so sometimes you want to just check and try to see, is this being normalized by default? Are those parameters hard-coded? Is it something I can change somewhere? Just as like one of these weird like hidden things that can sometimes be happening. Doesn't look like they're normalizing by default here.
Not what the divide by 255 is?
That's actually just scaling it to between 0 and 1.
Okay.
So that's not normalizing it in any way. That's just scaling everything.
A reason why you would not normalize?
So I think often it's best practice to normalize, though people don't always. I think it's more that there was a reason you would not normalize with values that are not actually taking you to normal for your data. So if you have camera trap data that's all sort of systematically colored a little differently than maybe like Facebook images, which is what ImageNet is kind of primarily, like online images, that normalization can actually end up sort of like suppressing the information on one of your channels or like making one of them like more important than another in a weird way. So there are like some strange artifacts that can happen. And so I just wanted to flag that for you guys, like check what the default normalization is. Yeah.
I'm curious, Sarah, then would, like in a case where the repo does have like kind of like image and averages or whatever, would you recommend like just calculating those numbers for your data set and replacing them, or just skipping or like not doing that normalization?
I would recommend like train it with the ImageNet numbers, see what happens, and then calculate those numbers for your data set.
Because those numbers are basically just like the average value of the red channel and the standard deviation of the red channel. It's like not actually a hard number to calculate.
Yeah, it's very, very simple. It's just like if those normalization values are just wrong for your data set, it can do some weird stuff.
Like bias everything.
And it'll just make your performance not as good as it could be. Yeah.
It's like Sam said, I think it is an easy calculation, but like in tech, like getting the mean and standard deviation correctly with the data loader where it's doing it in batches is like not so trivial. And I like looked for functions that do that, but it doesn't seem like there's like something that everyone uses, which is kind of surprising. So
this is one of the reasons that often these repos have global hard-coded variables for red, green, and blue that are calculated ahead of time on your whole data set, and they're just like hard-coded in somewhere.
So it's not a per batch normalization.
Yeah. It's the normal values that you've calculated on your whole data set. And this is again another way that out of distribution stuff can come into play, because if your color values are shifting out of distribution, now those normalizations are going to be different. And it's not really clear what the best practice to do is there. One thing you could try is like normalizing with different values that now match this thing, the hope that it's now been normalized into a similar space. Or you can try with the same values But it's just one more thing to watch out for. Like these normalizations do play a role. They can sometimes affect performance in like like several percent, like more than maybe some of the new architectures might. But yeah, just something to watch out for when you're exploring these databases is how do they handle normalization? Yeah.
I guess I don't like fully understand this, but can you just keep it exactly the way that it is in your data? Like whatever you're
without normalizing.
Without normalizing?
Yeah. You can do that. Yeah.
You can do that?
Yeah.
Okay.
Yeah, absolutely you can do that. And again, it's just like it might make things perform slightly worse, but I think that's actually a very reasonable starting point, right? Like before you start messing with normalization values, it's a very reasonable starting point to just be like, let's just try not normalizing and see what happens.
So that would mean just like commenting those sections of the code out?
So the hope is with a nice repository like this, that this sort of thing can all be specified in that config file, so you don't even really need to be changing a lot of code.
Okay.
Okay, so I think we're gonna do one more quick question. So call one more person up, and then I think I want to make sure you guys get a break before our invited speaker. So one more person.
Anybody want to volunteer? Yeah.
Jess? Yeah, Jess. All right, Jess. You're going to go back to that default config file, and we want to look at what the default data augmentation is specified as. So what's the difference between data loading and data pre-processing and data augmentation? Anyone have a guess or like an idea?
Augmentation would be like rotate.
Right, changing the colors.
Versus normalization, you're just sort of normalizing the pixel values.
Yeah, exactly. So that pre-processing is just like the resizing, the normalization, stuff that you do the same for every single image all the time. Augmentation is usually something that happens based on some given like randomness. So you don't always do it. And those randomness values are also something that you specify. So you can say, how often, like what's the flip a coin value I want to do for whether I randomly flip it from left to right. And often people use 0.5 for that. Like, okay, about half the time I'm going to flip everything. But there's a ton of nuance in terms of what data augmentation you decide to turn on and what those probabilities are. And all of it is really serving to sort of help regularize your model and keep it from overfitting on like specific pixels and specific images.
Sarah, do you pre-process first and then augment, or do you augment and then pre-process?
Pre-process, then augment. And that's mostly just because the pre-processing, like some of those augmentations are things like color jitter or randomly converting things to grayscale. And so you kind of want everything to be in the stable same position and then start messing with it at random, if that makes sense.
Jess, look in the default.
Oh. It's here.
So
CFG.
No.
YAML file.
Yeah.
Augmentation. That's true or false. Yeah, they're under prediction settings.
I think it's under hyperparameters, but I could be wrong.
So this is actually a bit of nuance. Do you want your data? Do you actually want data augmentation turned on when you're predicting, not training? So like after the model's trained and now you're just predicting on new images. Usually not. Sometimes it'll let you turn it, like you could turn it on, but I think often we do not want to be augmenting. We want to be testing on like the real images.
Would you not want to set your own augmentation?
So
So there's additional lines.
So absolutely. So we're going to go find where it's actually specifying that augmentation. And then here in this prediction setting, that augment false, that's just whether or not you should use all the augmentation settings you defined at prediction. So a lot of these things look to me like they have the word augmentation in them. So what are some of the options that are provided?
Hue saturation.
And okay, so you guys can see how there's like a value specified for a lot of these. That value is, and then they're putting in the parentheses, like some thing, like that's basically what that value is. So that HSV underscore S, you set that value, and that's the fraction of images that have HSV saturation augmentation, and how much you're doing saturation augmentation. There's also how many degrees of image rotation you want to do, or how much like image translation you would want to do. The interesting thing for these is that like different repositories do this differently. So like some of them are probabilities. So that flip UD, that's probably flip up down, so vertical flipping. Flip LR is horizontal flipping, flipping left and right. Those ones are probabilities. Mosaicing or mix-up, these are some sort of newer types of augmentation where you're basically taking two images and doing weird mid-blends of them together, and it's been shown in some cases to be a really useful augmentation strategy. Mix-up in particular has been shown to be very, very, very useful for audio. So for those of you doing audio, using mix-up might be a great option. But usually for myself, for the sake of a baseline and simplicity, I turn off everything except for left-right image flipping. Because what the right or the best values for some of these other augmentations are, you can go down huge rabbit holes with that. But if I'm just trying to get like, what's like a rough sense of like the simplest possible thing with like the least likelihood that I've like set some parameter that's doing something weird, my personal tack is I take like a very simple model, I do left, right, horizontal flipping at random, and I just see what happens. Because without even just a little bit of horizontal flipping, that does make a huge change in performance. Like the model will just memorize the set of matrices that are your training images, like pretty easily. Also, random jitter is another one that's like pretty straightforward. So like random translation. So you like just crop it at, like crop little bits of the image at random so that the matrix, like the values are not always identical in the exact same place in the matrix.
So if you transform the image, would you have to draw the bounding box? Because I think for Pytorch, I think they're testing out some new functions that could attach the bounding box to the image itself. So when you transform individuals, when they move, it like the bounding box is still the same.
Yeah. So this is one of the reasons why you use code bases like YOLO V8 for detection instead of default Pytorch, because default Pytorch didn't have a lot of supported data augmentations that supported like detection labels or segmentation labels or key point labels, because you need to do all of the same augmentations that you do to your image, you need to do to your labels. And actually, things like image rotation, you can't do that if you're doing detection, because detection assumes that boxes are square. And so if you rotate, now your boxes are rotated, it actually doesn't make sense and it'll break it. So these are sort of default parameters for YOLO in general, but image rotation is something that you often don't do with detection. Or if you're gonna do some rotation, then you have to make some weird choices about what you do with your box in that case. But yes, that's one of the main reasons that you use repositories like this is a lot of that, like making sure that in the code, the augmentations are also applied to your labels, like happens by default.
Sarah?
Yeah.
Can you speak more about image mix-up briefly?
Yeah, I can send you the paper for sure. But essentially what it's doing is you're basically like taking one image that has like an image of like something, like one category, and an image in another category, and you're like combining them. Like they'll take like a linear like mix of like the two. Yeah. It's maybe easier with with some examples. So it looks crazy, right? You're literally just coming up with some like combination of the two images, and they're kind of now just put on top of each other. But it's a type of regularization that's not necessarily as intuitive for a human, but it works quite well here. And then also, I think sometimes there's a lot of different versions of this, like, so it's hard to sort of say like what every single one of them do. But essentially, it's just another form of trying to like give your model information in as like a lot of different sort of diverse and complex ways so that it can't learn to memorize the easiest possible solution to the problem.
So I just mentioned that the readiness is really good for audio, it's because audio actually works like that physically.
Yeah.
So like if you have two sounds and you just add the spectrograms, it looks like the two sounds actually happen to be
Exactly, unlike images.
Right.
Yeah, because like that doesn't look, you're never gonna see that in a real world.
So here it's mixing two different classes. So you're asking the model to identify just one of, or learn just one of those classes, or it's become a multi-class problem?
There are different papers that do this differently. So there's some that use it as a regularizer, and then there's some where actually in the loss function when you're doing mix-up, it just actually then asks the model to kind of predict
Okay.
or it just changes instead of like a one hot, where you're trying to get it to predict the one hot, you try to get it to predict like 50% of each.
Yeah.
But there's many different sort of versions of how you use this type of signal. I think the simplest one is you just use it as a regularizer. So you're still asking the model to predict one of them, and then maybe your mix-up value wouldn't be 50%. It would just be like some lower amount. So like one of them still is dominating.
Yeah.
Yeah, there are a lot of different really amazing and constantly developed augmentation tricks. And the cool thing about these repositories is that often because they're so well supported, those are getting built